Hi everyone, I'm going to go over chapter 15, text page 407, problem number 7. If you want to pause this video and try this on your own and then check to see if you got it correct, you can go ahead and pause it. So I'm going to read the question. It says you draw a card from a deck. If you get a red card, you win nothing. If you get a spade, you win $5. For any club, you win $10 plus an extra $20 for the ace of clubs. Create a probability model. All right, so I added a deck of cards here on the bottom for your reference in case you weren't sure of the different suits. So this is a deck of cards. There are 52 cards in total. So we know our sample size is 52. So I'm going to go ahead and write 52 cards is our sample size. Now for the first situation, it says if you get a red card, you're going to win nothing. Well, let's look at our deck of cards. Out of the 52 cards, you can see that half of them are red. So the probability of picking a red card would be 26 out of 52. So I'm going to go ahead and write 26 out of 52. So the first thing I want to do is I'm going to just put the probabilities for each situation, and then I'm going to write it down in this model, or we can actually do that right now. So if you get a red card, you win nothing. So that means $0, and that probability is 26 out of 52. Okay, so $0 is a probability of 26 out of 52. All right, the next situation is if you get a spade, you win $5. So what is the probability of picking a spade? Well, if you look at the deck of cards, you can see that there's 13 of each suit. So the second row right here, this row, is spades. So there are 13 spades. So the probability of picking a spade is 13 out of 52. Now remember, all possible outcomes must add up to 1. So I'm going to keep the denominator as 52. I'm not going to reduce my fractions just to see that everything adds up to 1. So we got, if you get a spade, you win $5. We have that one. All right, then it says for any club, you win $10. So for a club, I'm going to get $10. So I'm going to write $10 for any clubs. And again, we have 13 clubs right here. We have 13 clubs, but the situation is a little bit different because there are 13 clubs, but it says if you get an ace of clubs, you get an extra $20. So why don't we start with the ace of clubs? So that means you will get $30 if you get an ace of clubs. Why is that? Because 1, it's a club, and 2, it's an ace of club. Because right here it says you win $10 if you get a club, any club, and $20 if it's the ace of clubs. So that means a total of 30 if you get this card right here, ace of clubs. So the probability of getting an ace of club, you could see right here, it's 1 card out of the whole deck out of 52. So if you get any other club, that means it's $10. So if you look at it that way, working kind of backwards from this situation, you'll see that any other club, meaning the remaining of these clubs right here, would mean 12. So 12 out of 52. Now let's make sure we have all our possible outcomes and that they add up to 1. So if you go ahead and add up 26 and 13, that is 39, plus the 1 here is 40, and 12, that is 52. So this makes sense for our probability model. The next question asks, find the expected amount you will win. So remember what the word expected means? It means the average. And we saw from our notes that the average, or mu, we can write mu of x, is also equal to our expected value, which is we we can write capital E of X. And we can actually calculate this by hand. That would mean, if you remember, it would mean multiply the first value, which is our random variable X. In this case, we called it amount we win. Multiply that by its probability, then add it to 5 times that probability. And so actually, I'm going to type it out over here. So that would mean, if I type this out, it would mean 0 times its probability, which is 26 out of 52, plus add it to 5 times that probability, which is 13 out of 52, plus add it to the third X, which is 10 times its probability, which is 12 out of 52. And then add it to the last one, which is 30 times 1 out of 52. That will give us the average or the expected value. So let's go ahead and calculate this. You could easily do this by hand, or you could enter your lists into a calculator. So remember, this is if you were to play the game many, many, many times. On average, you would win about $4.13. So let's go ahead and write that down. So all of this is what the calculator calculated for us, and that would be right here. I could enter it as $4.13. So if we played this game many, many times, we would be expected to win about $4.13 on average. So the last one says, what would you be willing to pay to play this game? So of course, everyone has a different opinion and a way to answer this question, but using statistics, how much would you be willing to pay knowing that if you played this game on average, you would win $4.13? So one possible answer would be, well, if I win $4.13, I certainly wouldn't want to pay more than $4 to play this game. So maybe anything, maybe $2 you could be willing to pay. That's up to you, but you certainly wouldn't want to pay more than what you could win. And this pretty much concludes this text problem.